We are going to check out here the answers and explanations for the January 2020 Chemistry Regents exam, Part B-1. Make sure you have your reference tables out. You're going to use them a lot in this section. We're going from question 31 through 50. Let's get started. All right, so for the first one here, we have a table and we have, subatomic particles for 4 different atoms, A, E, G, and J. And we're asked which atom has a mass of 12U. U stands for atomic mass units here. And you got to remember that an atom's mass comes from 2 subatomic particles, your protons and your neutrons. So literally all you're going to do here is add them up. The first one, 4 plus 4, well, that's 8. Can't be atom A. 5 plus 7, oh, wait a minute, that is 12. That's going to be our answer. Let's check the other two. 6 plus 7, that's 13. Can't be G. And then 12 plus 12, which is 24. The answer here was choice 2. Moving on. For question 32, which electron configuration could represent electrons in a sodium atom in the excited state? Excited state means that I have one or more electrons that are further away from the nucleus of the atom. Sodium, notice they did not give you the symbol here. If you do not know it is Na, then to double check, always go to reference table S. All of the electron configurations are on the periodic table. They are for the atoms in the ground state. But I would suggest for this, going there first, finding the sodium atom ground state configuration, and then come back and work through the choices. Sodium is Na. Here it is. Electron configuration is below the atomic number. If you forget, just look at the little key here. 2-8-1 is for sodium in the ground state. The other thing, of course, to recognize 11 is the atomic number, which is the number of protons, but for an atom, it's also the number of electrons. Let's go back and answer the question. All right, with that information, we know that sodium is element 11. The numbers have to add up to 11, which you can't. Choice 1, it's only 10. Choice 2, 281, was the ground state for sodium, and it's got to be an excited state. Choice 3, when I added up, I got 2 plus 7, which is 9, plus 1, which is 10. Not enough electrons. The only one it could be, and is the answer, is choice 4 for sodium in the excited state. Moving on to question 13. What is the number of valence electrons in a nitrogen atom in the ground state? Well, your valence electrons, remember, are your outermost electrons. Nitrogen, again, you'll notice they didn't give you the symbol. The symbol is N, but if you forget, yes, reference table S. Let's go to the periodic table. Your outermost electrons are going to be the last number in the electron configuration, which is 5. Another way to know that nitrogen and everything else in this group has 5 valence electrons is based on the group number. Drop the number 1, and the number is 5. That's going to be our answer. Now, notice I'm still going to the periodic table, even though I know it's 5. When you're taking a test, double check. You have the reference table. It takes just a couple of seconds. Double check your answers always. So the answer was choice 1. Moving on, 34. Graphite and diamond are both solid forms of the element carbon. Which statement explains the different properties? Well, graphite and diamond are known as allotropes. Allotropes is one of the vocabulary words that you need to know for the chem regents, but they never seem to use the actual word allotrope. What does it mean? You have atoms of the same element, but the arrangement is different, so the structure is different, and that means then the properties are different. Let's take a look. Diamond does not have ionic bonding, and graphite metallic can't be choice 1. Diamond, metallic, graphite, nope, can't be choice 2. Now, with choice 3, has a different crystalline structure, that is going to be our answer. Both are made of carbon atoms only, but the structures are different, which gives them the different properties. And has nothing to do with, there's no more valence electrons in choice 4 because it's carbon atoms. There's my answer, choice 3. All right, in question 35, you're asked to figure out percent error, but you got to go to table S to get what's known as the true value. This 143 picometers is the measured value. So I had to go to the second page of reference table S, find my platinum, it is PT, and go all the way over to this last column for atomic radius. The answer is 130, or actually not the answer, but the true value is 130, and now I have to plug it into my mathematical formula. I'm going to put the numbers right here on reference table T. 143 was the measured value. 130 we looked up is the accepted value. So 143 minus 130 and then divided by 130 times 100. Now you're going to want to use your calculator and don't skip the step. Just say, oh, okay, yeah, I got it. If you don't practice it and make sure you're getting the correct answer, then what you're going to do is you're going to set yourself up to make mistakes on the test. And that's the last thing you want to do. The answer you should get is 10%. And now let's go back and see if it's one of the choices. All right, for question 35, 10% it is. We have our answer. Because remember, you got to multiply by 10. When students skip steps, that's when you make silly mistakes. We don't want to do that. For question 36, what is the chemical formula for sodium oxalate? If you forget, once again, the symbol for sodium, look it up on reference table S. That is Na. And hopefully you recognize that oxalate is not just for one nonmetal. Choices 1 and 2 are oxides. That can't be the answer. So it's either going to be choice 3 or choice 4. Notice the only difference is the number of sodiums. Let's go to reference table E. We need to find oxalate and its charge. We're at reference table E. We go down, we find oxalate. And for oxalate, it's a -2 charge. This is where you use the crisscross method. You might remember this, practicing this with your teacher. Sodium is in group 1. It's +1 charge. Oxalate, C2O4, -2, meaning it's gaining 2. What am I going to do? I'm going to crisscross the numbers to balance out the electrons lost and gained. That means I need sodium with 2, Na2C2O4. Let's go back. And with that, we end up with choice 4. All right, let's go to 37. We're given a formula. What is the molecular formula of this compound? What you're looking at is called a structural formula. And all we're going to do is just collapse, just count. Let's start with carbon. Why? Because that's what the choices are starting with. Carbons, I have 1, 2, 3. And then for hydrogens, I have 1, 2, 3, 4, 5, 6. So C3H6. And here it is, choice 4. Question 38, which equation represents conservation of charge? These are half reactions, and what's been stripped away is called the spectator ions, where we're looking at what's being lost and what's being gained. Anytime you see charges on both sides of an arrow, you do have to worry about conservation of charge. Normally, when you look at equations, you don't necessarily see that because everything is together, even if they're ions in solution, as an aqueous solution. And yes, they would be separated. They're still written together in an equation, so you don't have to balance the charges. But here you do. It's got to be mass and charge. For choice 1, I have 1 iodine here on the left, and I have 2 on the right. It does not balance in terms of mass, so don't even bother going to charge. For choice 2, I have 2 iodine, and I have 2, so it's balanced in terms of mass. Let's go to charge. 2 times a -1 is a -2, and then 2 electrons is a -2. I think we have our answer here, choice 2. Let's double check the other ones, though. For choice 3, I start with 2 BRs, I end with 2 BRs, but I have no charge here on the left, and I have a total of -4 here on the right. Can't be choice 3. And then for choice 4, I start with 1 BR, I end with 1, but this overall on this side with the 2 electrons is a -2 and only a -1 on the right. The answer for 38 was choice 2. All right, moving on to 39, which represents a single replacement reaction. Before you even look at the choices, you should remember what single replacement is. You have an element plus a compound forming an element plus a compound. Choice 1, nope, that's synthesis. Choice 2, oh, wait a minute, that might be our answer here. Element, compound, compound, element. I think that's it. Choice 3, decomposition, and choice 4, double replacement. What's double and double replacement? You start with 2 compounds, you end with 2 compounds. So 39 is 2. Let's move to 40. The bond between 2 atoms is most polar. If you want to know how polar a bond is, real simple, you need to look up electronegativity values. They are found on reference table S. Electronegativity, another one of the vocabulary words you have to know for the Regents, and that is how much an atom is going to pull electron or an electron towards itself in a bond. We need to take a look. I can tell you right away, choice 2 can't be the answer. Yes, you're right, because it's fluorine bonding with itself, so the electronegativity difference for the 2 values would be 0. But we need to look up the other 3 choices. Okay, so what I did was made a notation of the electronegativity values for the different elements, and over here on the right side, I wrote them out and then put the values with them. And a carbon-oxygen bond is going to have less of electronegativity difference than the hydrogen-oxygen, right? The 3.4 and the 2.2, and then that's going to be a greater difference than my nitrogen-hydrogen, which is 3.0 and 2.2. So the answer here has to do with hydrogen-oxygen. The greater the electronegativity difference, the more polar the bond, and that is our hydrogen-oxygen bond. All right, we're halfway there. We've done 30 to 40, that's 10 questions, and now we got 41 to 50. Maybe take the last 10, do them, and see how you do. And hopefully you're doing okay. Just keep working hard. If you're making mistakes, it's okay. You're not taking the test yet. Let's go. Here we are, question 41. The volume and temperature of 4 gases at 100 kPa. In other words, they're all at the same pressure, and we're asked which 2 gases have the same or equal number of atoms. Well, they're all noble gases, so we don't have to worry about, the number of atoms in a molecule relative to a noble gas, which is only 1 atom at a time. What we're looking for here is, are they at the same temperature? And if they are, then the difference is going to be the volume. The larger the volume, then the larger the number of atoms. All right, if they're the same, then they have the same number of atoms. This is Avogadro's law. We have helium with a volume of 1 liter and 25 degrees Celsius for the temperature, and argon has the exact same conditions. So under the exact same conditions of volume, temperature, and pressure, they're going to have equal numbers of atoms. And that would then be helium and argon, which is choice 2. And let's just double check. The next one, neon, has double the volume and double the temp. Can't be. And krypton had double the volume and the same temp. So the only answer it could be there is choice 2. Moving on to 42, we have a solution equilibrium here. Ah, yes. And we're going to end up with Le Chatelier's principle. In other words, we're going to stress out the system here. We're adding sodium sulfate, and this is going to increase the concentration of the sulfate polyatomic ions. When you add something to a system at equilibrium, the shift is away from the side you add it. So AA, add away, TT, take towards. So the equilibrium is shifting to the left. So right away, this is a 2-for-1 type question. It's asking if it's shifting left or right. Can't be right. It's not going to go towards. It's going to go away. Cross out 3 and 4. And then what happens to the barium concentration in the meantime is we're not adding any more barium ions. So the concentration of my barium ions is going to go down. And that makes the answer here choice 1. Moving on to 43, we are given a compound. This is an organic compound. How do I know that? We have carbon atoms in a chain. And what is the chemical name for the compound? Right away, you should be thinking reference tables, but let's take a look at what we have before we get there. As far as carbon atoms, we have 1, 2, 3, 4, and that makes the prefix but. There is a reference table for that, and you'll notice all of the choices have B-U-T. It's not but, it's but. And then we're looking to see what is the family or group that this compound is part of. Well, we have an oxygen here, and we have nitrogen. There is going to be only one class of compounds where we have both oxygen and nitrogen with carbons. Let's go take a look. Okay, so for our class of compounds, they're also referred to as functional groups. We're looking at reference table R. And we're looking for, remember, oxygen and nitrogen. You just keep going down the table, and sure enough, we see nitrogen with amine at the bottom, but there's no oxygen, so it can't be amine. It's got to be amide. You got your C double bond O and your nitrogen. The ending here for any compound that has those two atoms as part of the molecule is amide. Let's go back to our choices. Based on that, the only choice it could be is choice 3. Moving on to 44. Okay, we have a potential energy diagram, and we're asked which interval represents the heat of reaction. Heat of reaction, the symbol is delta H, and remember, that's the energy, the potential energy of my products, minus the potential energy of my reactants, and that is shown here with arrow 2. So the answer is choice 2. For 45, we are with electrochemistry here, and redox, it says when comparing voltaic cells to electrolytic, oxidation occurs at the, well, anox, red cat folks, the anode, no matter what, is where oxidation takes place. And so that would be for both types of cells. The answer is choice 1. Moving on to 46, we're going to go to reference table J. Which metal is more active than tin, but less active than zinc? Once again, they did not give you symbols. If you don't know, the symbol for tin is SN, and for zinc it's ZN, and look them up on reference table S first. Let's go to table J. Okay, I'm at reference table J. We're looking for tin and zinc. I'm just going to scroll down so you can see this. And we were told more active than tin, which is here, but less active than zinc. One of the choices then better be Cr, Fe, Co, or Ni. And let's take a look. All right, for 46 then, we found Cr. That's choice 2. That's our answer. We're moving on to 47. And 47, we have a titration. And notice we have volume and molarity for HCl, an acid, and then volume for a base. And we're asked what's the concentration of the base. Well, we need the titration equation, also sometimes called the neutralization equation. We're heading to reference table T, so I can show you where that is, and then we can calculate our answer. All right, we are scrolling down table T, and here we are at our titration equation, and we're going to have our molarity of our acid and volume on one side, and our molarity of the base and our volume for the base on the other. All right, so I wrote down the equation, and you see I put acid on one side and base on the other. HCl is my acid. It's a monoprotic acid, meaning I'm getting one H for every HCl, so I don't have to worry about any kind of factors. And KOH is my base, and I'm only getting one OH for every one KOH. I don't have to worry about any factors either. So at this point, I'm just going to go ahead and plug in the numbers here. And let's see, we got 10 mils for our volume, and we had 0.075 for my acid side. On my base side, I have 30, and of course I have an X. Now I just have to plug it into the calculator and grab my answer. And calculating the answer, I'm getting choice 1 for 47. 48. Which emission causes the atomic number of a nuclide to decrease by 2 and its mass number to decrease by 4? Well, if you're talking nuclide, of course you're talking about a radioactive isotope, and emission means it's coming out of the nucleus, the atomic number decreasing by 2 and the mass by 4 can only be one thing, and that is a helium nucleus, also known as an alpha particle. But let's check the reference table just to make sure. Here we are at reference table O. You see the 4 and the 2. And if you hear any growling behind me, that's Ringo, the dachshund. And that makes our answer alpha particle, which is choice 1. For 49, we're looking at the bright line spectra for 4 elements, and then we have an element that's undefined, and we're asked to identify it. Well, you're going to play the matching game here. Every line on this unidentified elements spectra has to match. When you're going through this, before you even start, double check the wavelength numbers right on the scale to make sure that they are matching up with these elements. New York State has sometimes moved them over, which makes it harder to make a match. And it's not saying it's a combination of elements here, it's just one. Just moving from left to right, this first line, the only thing it could be is L or M. Definitely by the second line, we can tell it's got to be L, because this line matches with that. Then the rest of them, they all match up. They're all the same scale. Our answer then was choice 1. One more question here, and we're done with the multiple choice. All right, for question 50, we are dealing with 2 nuclear reactions. Well, you might say, well, wait a minute, how do you even know that to begin with? When you see mass numbers and atomic numbers and reactions, you're dealing with nuclear reactions. In the first one, in equation 1, you have uranium being hit with a neutron and then splitting apart, and you're getting 3 neutrons out for every 1 that goes in. That is known as fission. For question 2, you have 2 hydrogen nuclei coming together and making helium, and that is fusion. Can't be choice 1, can't be choice 2. Equation 1 is fission, equation 2 is fusion. That is choice 3. Besides fission and fusion, you have to know the natural radioactive decay reactions, your alpha and beta decay, and you have to know artificial transmutation as well. You have to recognize them with everything that you're doing. Keep working hard, and good luck.